an interesting topic for students, researchers in the area of healthcare management, healthcare engineering, and logistics, students and researchers. I will talk about the home healthcare, my experiences, my researches in this field, and first of all, I will talk about the motivation of the needs and benefits, why we have to develop a home healthcare routing, scheduling, optimization model algorithms, why we need new practical optimization models and algorithms. Then some recent ideas, trends, and contributions to this field are presented. I will talk some ideas how we can develop a new optimization model in the field, and what are and finally I provided some recommendations for future works, especially for students who are interested to do a thesis in this title. Yeah, generally, the home healthcare services are highly growth during these years, because the world is have many old people, elderly people who need to have such a services, and it should be noted the people who the life expectancy around the world has been increased, and this highlights the role of home healthcare services and around the world. And in the map, you can see many countries have some experiences in home healthcare, and the developed countries especially are have this problem, because the life expectancy in the developed countries is very high in comparison with the developing countries like Middle East countries or African countries. The home healthcare services are provided by a home healthcare company, which is can be the government or a company who aims to provide such services. To satisfy the demand of a large number of elderly people with disabilities, children, chronic illness, and functional disorders, we need to provide home healthcare services, and these services are very useful to address this big demand. Therefore, we need to provide a very efficient plan for routing and scheduling of caregivers to visit the patient's homes, and with regards to real-life constraints in the home healthcare in our life. So, a home healthcare company should do a collection of information of patients from their names, their history of illness, and many other information which should be collected. And when a patient requests an appointment for a home healthcare service, he or she should provide all his or her important information to help the company to assign a caregiver. Then the company should take care of routing and scheduling of caregivers to visit the patients at their homes. Therefore, the optimizing the total cost is very important for the company, and the company prefers to reduce the cost. And the caregivers usually include a set of doctors, nurses, physiotherapists, and nutritionists. And the company in each time select one of them to for each patient. The importance of this field highlights and motivates many journals to contribute to the home healthcare routing and scheduling. This is a review for some journals before 2019 that many journals are very active in this field, like European Journal of Operation Research, Computers and Operation Research, Expert Systems, Journal of Clinical Productions, Healthcare Management Science, and many other journals which are very active and which are interested to this topic. Therefore, if you want to write a paper, you can think about some of these journals, also the other journals that I will share with you that I have published in them. So here I want to introduce a basic model and then some solutions for the home healthcare routing and scheduling problems. Generally, the home healthcare optimization is based on two combinatorial optimization problems. First, the vehicle routing with time windows, VRBTW, that the base model. And another model is a nurse rostering problem. Therefore, in the home healthcare optimization, we combine these two basic problems in an integrated way and consider some real-life constraints and situations to model this problem. I want to present a very simple model for the home healthcare. In this model, we have only one pharmacy and one laboratory and many patients, and we have set of caregivers and transportation systems like vehicles. Therefore, there is a distance between each patient, the transportation cost with regards to the type of vehicles, the capacity of vehicles, the working time, the time window, including the earliest and the latest service time, the traveling time between to travel from a patient to another patient, and maximum desired travel distance. It is regards to the route balancing that I will talk about it later, and demand of patients, and also the amount of biological samples which are collected from the patient after the visiting. And the main decision variable for this problem is X, to assign a caregiver or a nurse to a vehicle to visit a patient before another patient. and other variables are continuous or integer, and the main decision variable is a binary. Therefore, if we want to define a search space, we should focus to the main decision variable. So the objective function is to optimize the total costs for visiting the patients, and also the cost for the route balancing. I will talk about route balancing later. The constraints are very similar to the vehicle routing problem with time windows. That should we visit each patient once time, and we should assign one vehicle to each tour of visits. We should consider the capacity constraints, and each nurse or caregivers starts from a pharmacy, and after visiting the patients, they back to the laboratory. This constraint number 7 is an important type of constraints for routing optimization problem, that is a balance constraint between inputs and outputs for each node as a patient. And time window constraints number 9 and number 10, and constraint number 11 is for the route balancing. In the route balancing, we should want to have defined an important and a desired number, a desired value for the each tool, that if a caregiver wants to do overtime, its tool may be bigger than the desired value for the each tool. It means the maximum, the summation of all visits. And we have provided a penalty cost if a tool has a greater value than the maximum desired value of distance for visits, and this includes the overtime of for the caregiver's working time. That's we have a penalty cost for the overtime working. To define the solutions, I firstly provided the Lagrangian relaxation reformulation for this model, and also then I will provide some other heuristic solutions, and then we will talk about some other ideas in the area of home Husker. In the Lagrangian relaxation reformulation, we should provide a new reformulation of the base model to reduce the computational time, and also to have and to keep the optimality. It means that when we relax an important or set of important constraints from the model, the solutions would be a lower bound for the base model. It means that it is optimal but not feasible, because we relax a number of constraints for the base model and put it with a Lagrangian multiplier in the objective function. And in the Lagrangian algorithm, we work and update the Lagrangian multiplier each time to provide a better lower bound. It means that an increase to the amount of Lagrangian multiplier as an subgradient or an adaptive parameter, we have this ability to provide a better lower bound for this objective. That this factor is very has a very important impact on these constraints for the base model. And for the developed to end also the Lagrangian not only improve the lower bound but also tries to improve the upper bound. The upper bound is a solution which is clearly feasible, and it is built based on the lower bound. That I should do some changes to the lower bound solution to make it feasible, but not optimal, to make it only feasible. And this feasible solution would be the upper bound. And in each iteration, I should update Lagrangian multiplier. Then I will stop if the maximum number of iterations is satisfied, or the lower bound in equation 15 reaches an feasible solution. Then the lower bound would be feasible. It means that we find a very good optimal solution for the problem. Because the routing optimization is the combinatorial optimization problem, it is still very difficult to solve these optimization problems by exact methods or any other reformulation techniques like Lagrangian relaxation, as I told you, or Bender's decomposition as another important technique for reformulation of a complex optimization problem. Therefore, we need to define some meta-heuristics or heuristic meta-heuristics for the base to find a very optimal solution in reasonable time, because it should consider that the home Husker planning are made daily. It means that we should, in each day, we should think that what is the planning of the caregivers. For example, here in Sunday, we should define the planning for the Monday, and therefore we need to have some quick and very efficient algorithms to solve the home Husker problems. The search space for this optimization problems is based on the variable x as a main variable, that I should define that what is the vehicle for this caregiver and what are the sequence of visits for this caregiver. And to define such important values to make a feasible solution for the base model, first I should redefine the total cost. It means that I redefine the cost as a new matrix in equation 18, that I redefine the total cost with regards to the cost of vehicles, for cost of transportations, and the distance matrix. Then I define 3 decision rules to do or to make a solution. First, for example, in the first heuristics, the tour is started with a patient which has the minimum value of digit of the first row of the matrix in this matrix. And for example, the closest patients is considered in the first heuristic. In the second heuristic, I select a patient with the average of total distance matrix to to a start. For example, among the patients number 3 have an average of distance matrix to as that can be considered as the first visit. And in the last algorithm, I provided and I choose a patient which has the minimum digit of the last row in the matrix presented in equation 18 as the redefined total cost. Therefore, I maybe select a patient which is a little far from the pharmacy and it may be closer to the laboratory. Such a decision rules are provide the local search components to define a solution for the problem. And we can, to define a neighbor, we have a strategy to select the first visit, and the other visits are considered by the minimum distance from the first visit and the second visit. We choose a patient which is very close to another patient. An example for this problem that I have, for example, 2 vehicles, and this is the redefined total costs, and I provided the sequence of visits. We have 7 patients, and the average of each row is presented here. And the first heuristic rule firstly starts with the 5th patient. It means this value is selected as the minimum value in the first row. In the second heuristic, we start from a patient which has an average, a minimum average of total costs. It means that the second algorithm starts from the patient number 7, because the situation number 7 has the minimum average cost. And finally, the last heuristic starts from a patient from the last row, which has the minimum distance. It means that here you can find this patient number 2, which is has the minimum distance, and this patient is considered as the first visit in the heuristic number 3. And then after finding such solutions which are optimal but not very good, we have a heuristic to apply, and we should change the number of visits and the sequence of visits for each caregiver for each vehicle to consider that what is the another neighborhood for this solution. To define a neighborhood for this solution, we should change this sequence. I have used some random values because the random values are working with any meteoristic. As you know, meteoristic have some continuous operators like the particle swarm optimization, like ant colony, like other meteoristics that I will talk about the meteoristic in my next presentation. And I have used some random methods, and after sorting from the lowest value to the greatest value, I have provided a sequence of visits to specify that what is a neighborhood solution for this the local search algorithm, and also the types of vehicles for each caregiver is assigned by another random key method that it is starts from the different types of values. If, for example, if we have three vehicles, the random values are between 0 and 3, and then after creating random values by meteoristic, I will round such numbers, and after rounding them, we have considered that which type of vehicle can be used in our optimization model. Such operators help us to provide some new neighborhoods, and this would be such operators are repeated in each iteration to improve the solutions. And other steps are related to the main loop of your meteoristic. For example, if it is a taboo search, you should define a taboo list or such. If you have used a simulated annealing algorithm, in the simulated annealing, you should define the initial temperature and reduce the temperature in each iteration and such like that. Generally, more information for this paper are given here, and if you want to read this paper, I suggest to download this paper, and if you have any other questions regarding the model and solutions I presented, you can ask me by email. Now I will talk about some new trends and new ideas which are added to this model as the base model, and then I curated some new practical optimization models. And to solve such models, we have different ideas, we have different strategies, development of new reformulations by heuristics or meta-heuristics and such like that, the development of exact methods and development of many other techniques that can be used for solving such NP-hard optimization problems. In our paper, I firstly introduced the concept of green home Husker. In a green home Husker, we have an additional objective. It means that in addition to the total cost, I have considered the green emissions of vehicles. Therefore, as a bi-objective optimization problem, I should consider the the green emissions of the vehicles, and to solve such problems, many other ideas by heuristics and meta-heuristics can be applied. And also the route balancing, as we have it in the previous paper. Route balancing means that we have a penalty cost for each route if it is longer than a predefined value. If we have considered that the length of each route creates the working time for all working time of a caregiver, we want to reduce the overtime working, and we need to have a penalty cost for the overtime. But since this optimization problem is not contributed to the time, and we have the route as the distance, therefore we have considered that, for example, routing around 3 kilometers is appropriate or is considered as the maximum length of visits for a caregiver in a day. For more information about this paper as a Green Home Husker, I suggest to read this paper, and you can download it. And if you have any questions, you can ask me. Therefore, one idea is about considering the green emissions for the home Husker activities. Another idea is to make the model more complex. It means that we can consider this model as a location routing problem. So there are a set of pharmacies and laboratories, and it is also a multi-depot vehicle routing optimization. Then the Home Husker company aims to find the locations of pharmacies and laboratories before making the routing and scheduling of caregivers. For example, assume that the company want to rent some locations as the laboratory and pharmacy, and therefore if you want to rent a location as the pharmacy and laboratory for the company, we should select the locations. For example, in the city, I have many pharmacies and many laboratories, and as a company, I should consider that how is the distribution of patients. I have many patients in my zone. Therefore, I should select a number of pharmacies and laboratories, and to make a contract with them that there as a pharmacy and laboratories, I need you on Monday to provide the Home Husker services, and it is our contract, and I want to select such locations to do the Home Husker services. Then as the company, we should provide the routing and scheduling. Therefore, the second step is to assign the assignment of patients to each pharmacy. It means that, for example, the pharmacy in the one street, or for example, the name of Valias street is selected. Therefore, I should select the patients which are closest to this pharmacy, because I want to start the routing. I want to start the route of caregivers from this point. And finally, we have the location and routing problem. So that I should provide the routing of the caregivers, that each caregiver starts from his or her pharmacy, and after visiting the patients, he or she backs to the laboratory. To have more ideas, to see more descriptions for this idea, I suggest to read this paper. In addition to the type of green emissions, we have modified the home Husker as a supply chain, and we need to have a location routing problem. Therefore, in this paper, I have considered such ideas, and interesting readers can read this paper and ask their questions, their comments to me, and I will be happy to help them. Another important idea is that the possibility of outsourcing. What is meaning of outsourcing? Well, we can define two types of services. Services which can be individual or bundle. In the bundle services, it means that as a normal way, I should visit a set of patients which are together as a sequence. I should visit the patients in a sequence, and there are some patients which are very far from my locations. That means that for example, some patients is living in a village, and in this village I did not have any other customers or any other visits. Therefore, the possibility of outsourcing is contributed here, that I need to outsource such patients to an hospital as an individual service, that for example, in a hospital we need to provide an individual and specific service for them, and other patients which are close to the city, which are close to my pharmacy, can be considered here. Therefore, a real supposition for a home health care supply chain network is that the patient choose their company and their services according to the costs. For example, if the patient is very far from the pharmacy, we should have a large total cost to visit such patients and back to the pharmacy. And when a patient is very far from other ones, we need an individual service, and to reduce the total cost, a bi-level programming model is useful. I have formulated such ideas for outsourcing of services by a bi-level programming model, that I have a leader as a company and the follower as a patient, and the patient can choose that he or she needs an individual service or a bundle service that as a normal one. And in the bi-level programming, we can do and we can formulate such ideas to provide a sequence and to provide the solutions for such a problems. And more descriptions for such for this idea is presented in this paper. You can read this paper and ask your questions and comments from me, and then I will happy to help you if you have any other questions from the idea of outsourcing for healthcare services. That is a good trend for researchers and students who want to have a thesis in the area of home healthcare. And now I want to talk about uncertainty. Uncertainty is highly contributed in recent papers, and many papers have considered the uncertainty as a challenge because in real life the parameters are not deterministic, and we should consider the uncertainty. I have divided the uncertainty in two types: a deep uncertainty and the operational uncertainty. In a deep uncertainty, as a strategic, we have we need to reschedule the visits. It means that a patient may cancel his or her appointment due to some reasons. We don't know the reasons, but I have some appointments on Monday, and in the appointments on Monday, for example, some patients called to the company that we have a problem, or we have a for example a ceremony, or we have a we want to travel, or for example, yes, today we need to cancel the appointment. And when we have such events, which is done after I have created the schedule. I have created the schedule of visits, and then some patients canceled his or her appointments. Therefore, I need to reschedule the visits. And in this type of uncertainty is deeper, because we need to have do a real-time scheduling or a reschedule the visits of caregivers. And in this regard, I suggest to develop a real-time optimization as an idea to formulate such uncertainty. And the operational uncertainty. In the operational uncertainty, we always consider that the service and travel times are not deterministic because of driving skills, the road conditions, traffic, weather, and many other factors. We have some uncertainty in the service and travel times. To deal with such uncertainty, we can use very common uncertainty formulations like fuzzy programming, like stochastic programming, or robust programming, and all many other types of uncertainty modeling can be used. And the types of uncertainty, the types of uncertainty modeling that you are planned to use them, is all can be depend on you, and depends on your parameters and your contributions. That, for example, I have seen the literature, and I think the fuzzy logic is suitable to address the uncertainty for the service and throughout times. So I have considered the operational uncertainty in some of my papers, but as far as I know, there is no paper in the literature that to consider a deep uncertainty to have a real-time optimization. So in our paper, I have proposed a multi-depot home Husker, as we have a set of pharmacies, laboratories, and many patients with uncertain travel and service times. And in this paper, I have the main idea is about the patient satisfaction. The patient satisfaction is important, and I have measured it as an objective function. And I have used the fuzzy programming to model this problem. And these ideas have been applied to this paper, and I suggest the readers and the intensive readers to read this paper and ask me their comments and questions for the home Husker. For this type of home Husker, considering the patient's satisfactions and also considering a fuzzy modeling approach to formulate it. In addition to the green home Husker, I have also shifted the green home Husker to the sustainable home Husker. It means that in sustainability, we should consider the economic, environmental, and social factors together. The sustainability have been applied to many supply chains and logistics systems, but it is rarely contributed to the home Husker. Therefore, in this paper, I have considered the sustainability. It means that I have the economic for equality for the total costs. The cost of services or the cost of transportation can be considered the total cost. The environmental pollution from the green emissions of transportations can be considered as another criterion. And the last criterion is the social justice. That's if I want to find the balance between the working times of caregivers, to have considered both unemployment time and overtime. It means that both unemployment time and overtime is considered by plenty cost, that it is not allowed to the system because the caregivers caregivers may give their salary by the hours of their working, and the hours of their working for a day is 8 hours. That in a day, 8 hours is the predefined time of working for a caregiver, and we do not want to have an employment time. That means that the caregiver is only worked for 6 hours, and it is not good for us as a company, or the caregivers should work the overtime. Oh, and we have to pay an additional salary to him or her for his overtime. Therefore, the consideration of both unemployment time and overtime of working for a caregiver can be considered as a social factor, and considering all economic, environmental, and social factors simultaneously develop a sustainable home healthcare logistics. Therefore, the concept of sustainability needs to have all economic, environmental, and social. To also consider that we have the uncertainty for the travel and service times, we can apply a robust optimization. In the previous paper, I have applied fuzzy programming. In the new paper, I have considered the robust optimization. The robust optimization has been applied to the uncertainty of travel and service times, and I suggest to you to read this paper for the sustainability of and the robust home healthcare logistics, and you can read and download it. And if you have any questions about the models, the solutions, algorithms, and all like that, you can ask me by email, and I will be happy to help you. If you want to do an extension to this paper in your thesis or in your researches. And the last idea is to that in addition to the working time balancing, which is considered as to minimize the total unemployment and overtime, we should consider the care continuity. What is the meaning of care continuity? It means that if a patient requests a home care service, then the person as a caregiver who is responsible is very important. In a care continuity, we can consider that some patients will be happy if they have a same caregiver for all his or her appointments. That in his or her appointments, if possible, we can select the same caregiver. It means the same person for each visit. It means that the caregiver improves the quality of the home care services, and to improve the quality of home care services, the care continuity is an important factor. And in this paper, I have considered the working time balancing and care continuity together as an optimization problem, and also I also have considered the uncertainty for the service and travel times. And to this end, I suggest you to read this paper about working time balancing and care continuity, and you can ask your questions and your comments about how we can develop another optimization problem and do an extension to this paper by reading this model and develop a new paper. So and finally, I have provided some very interesting ideas for you if you have a plan to write a paper in home healthcare. I have shared some ideas and the combination of ideas that have not been studied before. One recommendation is that the synchronized visits, route balancing, and working time balancing has not been considered simultaneously. What is the synchronized visits? In synchronized visits, for an appointment, we need to do two services in a sequence for a patient. It means that first of all, we need to have a caregiver as a nurse to provide some services, for example, for the cleaning, for the keeping, and the keeping, and some other services for the patient. And after a nurse visited a patient, the patient needs to have a doctor to check check his or her healthy situations and recommend some new drugs or some new receptions for these patients. Therefore, as far as I know, there is no study to consider the synchronized visits, route balancing, and working time balancing in a simultaneously. As I mentioned earlier, all the models, all the types of uncertainty in the literature are only considered the operational uncertainty related to the travel and service time. But there is no paper, as far as I know, as an expert in the field, that contribute a deep uncertainty for and develop a real-time optimization. Therefore, as far as I know, there is no real-time optimization approach for the home healthcare services, and this can be done by you if you are interested, and if you got this idea, and write your paper as soon as possible in a very comprehensive and very good way. And so I shared my idea about outsourcing, that I have done it for the first time, but there is no paper to consider outsourcing of services in an uncertain way. It means that with considering the uncertain factors like travel and service times. Therefore, the possibility of outsourcing with uncertain factors like travel and service times is suggested for all as a contribution to write a paper. And finally, as I talk about the importance of heuristics and meta-heuristics in my first slides, and develop some local search components and search space and neighborhoods for this problem. And always the development of new heuristic and meta-heuristics is recommended, because it is an NP-hard optimization problem. And if you understand, and if you have provided new strategies to assign the patients to a caregiver, in the first slide, in this presentation, I shared 3 strategies to assign a patient to a caregiver using a matrix and redefine cost and something like that. And if you have new ideas for development of heuristics and meta-heuristics, it is a very good idea to write a paper. And finally, as I have read in the literature, and as I have know the literature in a comprehensive way, the Lagrangian relaxation is used commonly in the literature, and I have used Lagrangian relaxation in many papers. But the Bender's decomposition is rarely used in the literature. Only 2 papers have done, and both 2 papers were written by a colleague in Montreal, by Professor Lahrichi, and I know her very, and I think many other researchers can apply the Bender's decomposition for our optimization models that we introduced here for the working time balancing, career continuity, and many other considerations such as the outsourcing of services, and all of these complex items can be reformulated by Bender's decomposition approach. And
okay, thank you very much for your good presentation. Dear participants, if you have any questions, please type in the chat box. We have 50 minutes at most for question and answer section. Dear Mr. Fathollahi, if allow me to start, as a question, I would like to know how these models can be applied in practice, especially in the presence of COVID-19. Have you known any company in Canada to start a platform business? However, in Iran, for instance, we see a Snap Doctor, which enable their patients to receive some services such as PCR tests. But I'm not sure, are they using an optimization model as a core in their platform or not? So if I shorten my question, whether the static optimization models are popular from the business point of view, or they prefer to utilize some simple rule-based dynamic heuristics?
Thank you. Yeah, my microphone is working. Yeah, the home healthcare services can be useful for the COVID-19 because of 2 main reasons. That we should consider the social distancing to reduce the rate of growth of pandemic, and we should consider the home healthcare services, and such home healthcare the tests for healthcare services like PCR test may be taken or considered in the patient's homes, and I think the home healthcare is generally matched with the COVID-19. As far as I know, there is no specific platform that has been applied to use a practical optimization model in the contents of COVID-19, but the concept of home care services for to reduce the social distance, to improve the social distancing, to visit the patients at their homes, not hospital to do the PCR tests and some like tests in the patient's homes. They are useful, and such a test can be formulated as a home health score, because the patients should take his or her appointment, and then we need to have a routing and scheduling for the services. I also checked the.
Thank you very much. Another question by Azim, I think that. Can we consider resilient routing healthcare with Industry 4 for future advances?
Yeah, resiliency can be applied for the two uncertain factors, especially the road conditions for the travel and service times, and resiliency with the development of new hybrid uncertainty approach, for example, a possibilistic, stochastic programming, or the fuzzy robust programming, or something other uncertainty modeling can be used to consider and to measure the uncertainty of operational uncertainty for travel and service times. But to me, only to improve the resiliency for the plan is to consider the rescheduling of visits after disruption. The disruption here is the patient canceled his or her appointment, and then we need to reschedule the visits. And this is a very good idea that I have not been studied before.
A question by Nastaran. Could you explain more about applying bi-level programming in this problem?
In the presentation, I tried to explain. In the bi-level programming, we have an upper level model and a lower level model. There is a link between the lower middle model and the upper level model, because the lower level model is a constraint of the upper level model, and the variables which have been solved in the lower level model are parameters in the upper level model. In my paper, I have considered the company, the home Husker company, as the upper level model. The company wants to first of all make the locations, make the location decisions for the pharmacies and laboratories, and then the patients, as the lower level model, can focus on the types of services. It means that he or she wants to have an individual service without any other services, because this type of the possibility of outsourcing refers to this idea that we have some patients which are very far from our zone in a city. For example, all of my patients are in Montreal, but I have, for example, two patients in Quebec City. Therefore, it is a very this is not a very economic. It is not economically that I have to provide a service for such a patients, and I need to define an individual service for them. by a hospital, that I can provide a contract between a hospital that you as a hospital should provide these patients, and all other patients are will be supported by my services. We will have pharmacies to do such services. So,
Okay, just two more questions. One by Zainab. It seems that machine learning techniques are more applicable in HHC scheduling than mathematical programming. Why did you prefer to apply OR approach in your paper? And the next one is that how can we consider this concept in scheduling service network design? Thank you.
yeah, generally at the,
It is
okay, let me check. Yeah, it's working. The routing optimization is a combinatorial optimization problem, and in the combinatorial optimization problem, when we have a large data, it is not possible to apply an operation research technique like Lagrangian relaxation, or renders decomposition, or column generations, or many other techniques, because the data is large. We have many patients, for example, thousands of patients in a day we should be serviced, and the plan for them is provided daily. It means that we cannot have many times to make this to find an optimal solution. Therefore, such a planning for the home healthcare services are very important, and we need to develop heuristics and meta-heuristics, define many efficient decision rules, some local search components, and some other techniques to apply in the home healthcare. And regarding the service network design, if we transform the service network design as an asymmetric routing, if we have consider some routing activities, for example, we can use our concepts in the home healthcare for some other supply chain network design problems, because the concepts using in the home healthcare, like synchronized visits, like working time balancing, like other many concepts in the home healthcare have been defined earlier in the supply chains. In the supply chains, we have defined the vehicle routing, we have defined the synchronized visits earlier, we have defined the working time balancing in the production scheduling earlier, and all concepts in the home healthcare have been previously defined in the supply chains and production systems, and therefore we can continue to develop new ideas for the home healthcare and apply it. And this application would be very customized to this problem, and we should consider such important characteristics of the home healthcare services.
Okay, I think that we cannot
We can
more discussion. If you like, you can answer two more questions. Just thank you.
okay. I think I have answered the questions, but I think my voice is not available. For the first questions regarding the bi-level programming, as I said in the presentation, I have used an upper level model and a lower level model. The upper level model is decided by the company, the Husker company, and the lower level model is considered by the patients. When we have a patient which is very far from our zone, for example, if we have two patients in a village and many other patients are in the city, therefore it is not optimal that I provided a service for them in a bundle, because we should consider a sequence of visits, and it's not optimal. Therefore, for some patients which are very far from our system, we can consider an individual service from the hospital that the company provided a contract for a hospital that the hospital you should provided the services for these patients, and other patients will be supported by my services in the company. In the bi-level programming, the upper level model is is a simple optimization problem, but the lower model is constraints for the upper level model, and these decisions are in a sequence. It means that we should first provide a decision in the upper level model, and then we have any reaction to the lower level model, and then the solutions from the lower model are back to the upper level model, and variables in the lower level model, for example, variables for the assignment of patients to the bundle or a visual service is made in the lower level model, and after we get an optimal solution in the lower level model, we now back to the upper level model, and the decision variables in the lower level model are parameters in an upper level model. And the sequence of decisions in two types of decision makers, it means the company and the patients. We have to use a bi-level programming when we have a possibility for making two types of that to address the preference of two decision makers, the patients and the company. And finally, regarding the questions about the research network design, I should say that the network design and some other old concepts for the home healthcare can be applied to the supply chain model. For example, the synchronized visits were previously in the vehicle routing, and we have to say that this concept can be applied to the home healthcare as well. The concept of working time balancing was previously applied to the production and scheduling, and then we have considered that we can have this constraint and these factors in the home healthcare services as well. Therefore, all concepts in the supply chains and production systems may be applied to the other applications if we provide a match between these concepts and other types of real situations for home healthcare services and practical solutions for them. Dear Dr. Mirzapur, can you hear me?
Thank you, Mr. Fathollahi. Sorry if I closed your microphone because it caused the voice echo. So I mute you and then I speak. Sorry for this interruption. It seems that the questions finished and we can terminate the session. Once again, let me thank Mr. Fathollahi for the time dedicated to us. Would you please send me the slides to share it with the participants, if possible?
I will send you the slides by email, and if applicable, I think if you have a record from this presentation, please also share it with me. I can share it in my channels, and it will be very useful.
Yes, sure. Thank you. At the end, I hope a good day or night, or night for all, and invite all the participants to participate in the next seminar. Will be held on tomorrow noon. Thank you again. Bye bye.
Thank you. Have a nice day.